Hi class, in example 5, we're going to be looking at technically absolute value equations and inequalities. And here's the basic idea. If you have an absolute value equation, you're just going to have technically both ends. In this case, negative p and p, and your solution is going to be just those two dots or some unknown that needs to be solved as you set it equal to p or negative p. If you have a statement with an absolute value that says less than or equal, you're going to be including, well, all the values in between. And then if it's an equal, then you're going to have brackets on those two. If it says greater, from your p-values, it's going to be to the right or to the left. So each of these problems, we kind of have to technically analyze it very carefully to make sure that we're either graphing or solving the correct statement. And also all the statements, we're going to be referencing them back to these three situations. Now, let's take a look at problem 1, and they just want us to graph the inequality or equation. And this one says absolute value of x less than 6. So I'm just going to put 0 as a reference, and I'm just going to put 6 and technically negative 6. Now, our solutions, because it says it's less than, we're going to be looking at this scenario here, or B. And technically, it's going to be in between those two. It's a less than, so we're not going to include the boundary. So open circle on the edges. And our solution is every value in between. All they want is technically the graph. So that's it for problem A. We're looking at an absolute value or all distances that are less than 6. Remember that on distances, you're technically measuring from 0 to less than 6 and 0 to less than negative 6. Let's take a look at problem B. Now, B, it says all the distances that are greater than or equal to 10. So technically 0, I'm just going to put 10 as a reference and negative 10. And as we're looking at all the distances that happen to be greater than or equal to 10, we're going to have closed circle here, and technically every value to the right, closed circle here, and every value to the left. In this case, we're looking at the inequality or the formula that's provided here as formula C. Any statement that says greater, it's going to be from the p-value to the right, in this case to the right, and to the left. But notice it says greater than or equal. So here the statement is greater, so you're not including these two because we're writing as greater than or equal. We're including them, so close circle or bracket. That's it for B. Take a look at C. And on C, it's an absolute value equation. So technically 0, I'll just put 4 and negative 4. Now, in this case, we're on the situation A or formula A. If you have an equality on P, you have to look at the positive and the negative because of distance. So in this case, we're just going to put the dots on positive 4 and negative 4. In this case, no shading because it's only asking for distances equal to 4. So from 0 to 4 and 0 to negative 4. That's it for C. D is a little bit tricky. And let me rewrite it as 0 here for the origin. And notice that you have a greater than or equal to 0. Now, we're technically looking at this formula, or technically formula C, but here it says greater than P, and notice that it goes from the value of P to the right and to the left. But in this case, it's saying greater than or equal to 0. So that means that our solution is going to be including 0 and technically all the values to the right, but also all the values to the left. So because the number happens to be 0, you're not going to have the gap that is stated here, which is this gap. So in this case, you're using the entire number line. If it had a larger value, then you would have a gap. In this case, there's no gap for that particular problem. And the solution or the graph is technically all the numbers on the number line. And in that case, from 0, we put a line with an arrow to the right and to the left. That's actually it for the last two. Absolute value equations only contain the dots, greater than or equal. They are shading towards both positive and negative infinity, but this one includes the 0. The other two, A and B, do follow the formulas given.